Hi guys, Miss Nadhouse here. I'm here to explain to you what you're going to be doing this week with your earthquake create project. So first things first is make sure that you've scanned your QR code in your science journal. Make sure that you have scanned this QR code right now and you have a copy of the science or the earthquake engineering journal. If you haven't done that, go ahead and pause this video and do that now. Okay, welcome back. Now let's talk about what you're going to be doing today. So during day one, you are going to complete the what's the problem. That's going to be on slides 2 through 5, which I'm going to show you in a moment. But you also have access to these slides. Again, if you go back to your science journal, you're going to see the Google Slides agenda for the week. You can go ahead and scan that, and it's going to take you to this presentation that I'm showing you right now. All right, so the first thing that you're going to do is you're going to complete the what's the problem on slides 2 through 5. Then you're going to plan and imagine a solution to the problem. You're going to sketch and label your plan. And if you have time today in day one, you're going to also start building your prototype or building your building. So let's look and see what those slides look like. So when we go to slide 2, Slide 2 is going to tell us a little bit about the problem. So make sure you read through this. What are we going to be doing this week? We're going to be designing the tallest building that can remain standing with no damage during an earthquake. So what's the problem? Many people die each year from earthquakes. Most of these deaths are as a result of collapsing buildings. Earthquakes can't always be predicted, but we can reduce their impact with the help of science and engineering. So that's what you're going to be doing today, is you're going to be designing buildings that can withstand different earthquakes at different Mercalli scales. We're going to be using our District 34 process. So we're going to start with our ask. What's the problem? We're going to discover. Today we're going to discover, and then you're going to plan. So again, our ask is, how might you design a tall earthquake resistant building? Here's the criteria and the constraints. So remember, the criteria are the rules. So you need to design an earthquake resistant building that is 25 inches tall. If you're not sure what 25 inches looks like, remember you do have that measure app on your iPad that you can use and just scan it from the bottom to the top so you kind of have an idea of how much further you have to build, or if you reach the 25 inches mark. Your building has to have at least 2 stories. That means you have your marshmallows and your toothpicks are what you're going to be using to build your buildings. And you need to make sure that it has a first floor and a second floor. The floor doesn't have to actually be built with the toothpicks, but we need to see that there's at least 2 stories. If it's 25 inches tall, I'm pretty sure you're going to have no problem getting those 2 stories in there. And it has to survive a 15-second quake. So even a partial collapse is dangerous in a real earthquake. The structure must be completely intact at the end of each round of quakes. And I'll tell you what quakes are in a moment. All right, so the constraints. Buildings will be constructed of only your tape, toothpicks, and marshmallows. If you don't have tape from that we've given you in previous challenges, please let your teacher know, and I'll make sure that you have some tape. So you should use masking tape, but if you have other tape at home, you could always use other tape as well. But if you don't have any tape, let me know and I'll get you some tape, or let your teacher know, and your teacher will let the science specialist at your school know that you need some tape. All right, your building must be built on a platform, and it must be able to stand alone. So when you're talking about standing alone, the tape can go onto your platform. So you can tape your building onto your platform, but you can't hold the building as it's shaking, because in the real world, there's nothing holding the buildings up other than the structure. All right, again, you can tape your building to your platform. Possible platforms are the styrofoam tray that was used in week 2, or you can just find a cardboard box that's around your house and you can just cut off a piece of cardboard. Or if you have another sturdy structure, you can use that as well. All right, so discover. So this is part of today, or this is what you're going to be doing the bulk of the day today, is you're going to be watching these 3 videos, and these 3 videos are going to give you some ideas and inspiration on how you should build your building. You might already have some ideas, and that's wonderful, but you might want to, or not, you might want to, you are going to watch these 3 videos and think about what they're telling you in each one of these videos. So what have you learned about engineering and earthquake resistant building, and how can you use these ideas in your model? If you have time, you're going to start planning. So if you have time, you're going to state the problem in your own, well, if you have time, you're going to start planning. So let's talk about what you should have done already in your science and engineering journal. So once you scan the QR code, you're going to see that you have this science and engineering journal. Let me go to the first page, sorry. So here's the first page of your science and engineering journal. In your own words, explain the problem behind this design challenge. Well, where would you have got that problem? From the slides that I just showed you. We just talked about the problem too. In step 2, what did you learn from the 3 Discover videos that I just showed you? And what features of the structure would be most stable during a strong earthquake? So think about what they said in the video to answer that question. And what kinds of shapes and structures seem to be more resistant to earthquakes? So in the videos, they kind of show you, well, if you do it this way, if you do it this way, this is what's going to happen. So keep those ideas in mind. Once you have your ideas, you're going to go ahead and start planning. So this planning piece, this sheet right here, is going to be done in your science journal. If you look in your science journal on the next page, you'll see that you have this page in your journal. You're going to need to sketch your ideas here in your science journal with your hand and a pencil or markers, and you're going to also label your drawing, and then you're going to take a picture of it with your iPad, and then you're going to insert your picture here into your earthquake engineering journal. If you have any questions about what you're doing today, please join the Science Zoom Help. The link for that, or the QR code to get you to the Science Zoom Help, is located on the first page of your science journal. Have fun today, guys.